Good afternoon. We're live from the LSU Center for River Studies, right here on the water campus in Baton Rouge, Louisiana. Today's day 2 of Coastal Week presentation. We're lucky to have Danielle Ricciardi from our CPRA New Orleans field office that's going to give us a presentation today. These presentations are building through Coastal Week to build a little excitement to Coastal Day, which will be Monday of next week, Monday, March the 30th. We've got a timeline and an agenda of events that will be happening Monday. The first event will be starting right here from 8 to 11 a.m., Coastal Connect, which is a business-to-business networking event, which will also include speed dating that'll happen right here at the LSU Center for River Studies from 8 to 11 a.m. At 1 o'clock, the excitement will move downtown to the Capitol. We'll have a briefing in the governor's press room on the 4th floor at the Louisiana State Capitol. At 2 o'clock, down in Memorial Hall, still in the Capitol, we'll have outreach to legislators that'll be going on so advocates can meet with our elected leaders and let them know how important some of the coastal issues are to them personally. At 2:30, we'll have an open house, the Deepwater Horizon oil spill open house. That'll be at the Galvez building in the Oliver Pollock room. Galvez building is adjacent to where DEQ offices are housed in downtown Baton Rouge. From 3 to 5 o'clock, CPRA will lead an event where we forecast the construction projects that we'll have that'll be going out for the next 18 months. So that's from 3 to 5 o'clock Monday at the LaSalle building in the LaBelle room, but will also be that event will also be virtual as well. At 5 o'clock, everything will move down to the Pentagon Barracks for a crawfish boil, where everybody can get together and kind of celebrate and break bread together as a group. The fun doesn't finish on Monday. Tuesday, March 31st at 2 o'clock, we'll have partner-led construction forecasts. So this is for parishes and levee districts and NGOs and other coastal entities besides CPRA that have projects going to bid in the next 18 months. They'll forecast their work. Next slide, please. So we just want to reiterate that at 2:30 to 4 o'clock, this will be the annual meeting of the Louisiana Trustee Implementation Group. That's the meeting that will happen at the Galvez Building's Oliver Pollock room. So the past couple of years, those meetings have been virtual and online. This will be live and in person, and it'll be an open house style. And it won't just be folks, representatives from the Louisiana Trustee Implementation Group. We'll also have representatives from the National Fish and Wildlife Foundation. The acronym for that is NFWF, and also from the Restore Council. They'll be in attendance at the open house. They'll have maps and information and be able to answer any questions you've got about projects that have been constructed or ones in engineering, design, or construction that are being funded with settlements from the Deepwater Horizon oil spill. Next slide. But this week, today and yesterday and every day this week during the noontime hour, we've got just a marvelous program, a dream team of presenters. And the topic that they're focused on is one of the objectives from our coastal master plan. One of those objectives is how do we harness natural processes to restore coastal wetlands? Next slide. So yesterday we had a tremendous leadoff presenter. Dr. Mike Miner talked about those presenters. If you missed Mike's presentation, you can Google the CPRA Vimeo page or our YouTube page, and you can watch a rerun of his presentation and enjoy that. If you go to the next slide. Today, Danielle will give us a presentation on the Davis Pond Freshwater Diversion. Next slide. Tomorrow, Brian Gossman, again, also a biologist from our New Orleans field office, will be giving us a presentation on crevasses and land building diversions in the Mississippi River Delta. Next slide. Thursday, we've got a dynamic duo, Burn Wood, from our Lafayette office. Natalie Mathern from our New Orleans field office will be presenting about terraces as a restoration tool. This is a fantastic presentation. Definitely can't miss TV. So next slide. And then Friday, batting cleanup, Elizabeth Gerald from our New Orleans office, Darren Lee from our Lafayette field office. Elizabeth will be presenting about hydrologic restoration, some gapping projects that CPRA has constructed to reconnect the hydrologic restoration in some of those areas. And Darren Lee will be talking about vegetative planting and capturing sand on our barrier islands. Next slide. So if you need to connect to any of the information for these presentations, you can go to coastal.la.gov On the right side of the web page, it says calendar. Under calendar, you can find links that'll provide connections to all these presentations. If you'd like to register for the Coastal Connect, the business event Monday, that can be done through louisianactac.org. So CTAC is the Coastal Technical Assistance Center. They help us with the registration and administration of that event, along with our good friends at the Apex Accelerator. Next slide. So we are live, and if you've got questions or comments or just want to share your thoughts with us, you can email those to us at coastal@la.gov. When Danielle's finished with her presentation, we'll ask her some questions or share your thoughts with her. Danielle, if you want to go ahead and load your presentation. So just really lucky to have Danielle Ricciardi from our New Orleans office here with us today to give us this presentation on the Davis Pond freshwater diversion and engineering with nature. So Danielle, take it away.
All right, Greg, thank you for the introduction. As you said, my name is Danielle Ricciardi, and I work in the New Orleans Regional Office for CPRA, and I am monitoring manager for our freshwater diversions. For today, I'm going to be focused on the Davis Pond freshwater diversion, and I'm going to be relating this diversion to our topic for this week, which is engineering with nature. So let me get started. All right. So, when engineering with nature, there are 4 primary principles that we're focusing on, and I'll be relating these to the Davis Pond freshwater diversion. The first one is when you're engineering with nature, you use natural processes. Uses riverine flow to attain the project goal of reducing saltwater intrusion. That is the main goal for the Davis Pond project. Additionally, we're looking to produce efficiencies by incorporating project features that are going to enhance project benefits. We're looking to broaden benefits. So in addition to maintaining or reaching the project goal, also looking at other benefits the project can have, such as creating and enhancing marsh and forested habitat for fish and wildlife. And then we also want to make sure that we are promoting collaboration. And this project is a collaboration between the Corps and CPRA, but there are also multiple other collaborators, which I will note during the presentation. All right, so before talking about the Davis Pond freshwater diversion, I did want to show all of the diversions that exist along the southern end of the Mississippi River. If you look at the one that's furthest north in the northwestern part of the slide, furthest upriver, that is the river reintroduction into Maurepas Swamp project. I wanted to call out that one because that is the one freshwater diversion project that we have that's currently in construction. It's going to be a 2,000 CFS diversion, and this one's particularly interesting because it's the first one that we're doing where we're introducing riverine water into a swamp habitat. There's going to be a lot of monitoring involved with this. This is a project we're working with the Corps on. They're actually using it as mitigation project for their West Shore project. So you'll be hearing a lot more about this project in the upcoming years. We're hoping to start operations of this diversion in 2030. Just a few others I'd like to point out. There's the Bonnie Carey Spillway, which is used as a flood prevention measure for the lower part of the river. That's our largest one by far, 250,000 CFS. But it is only used when necessary, when river stage gets really high. Davis Pond freshwater diversion is the next one that is noted, that is marked with a yellow star. That's what I'm going to be talking about today. And then also wanted to point out some of our natural diversions, like Mardi Gras Pass and Neptune Pass. Mike Miner talked a bit about Neptune Pass yesterday, if you were listening to that presentation. It's a rather large natural crevasse that we now have on the east side of the river. All right, so we'll start with the Davis Pond Freshwater Diversion. Just to provide a bit of a background about this diversion. It is a freshwater diversion. Its whole purpose is to provide fresh water to the Barataria Basin, and it is gravity driven, which means in order to operate the diversion at a higher capacity to have more flow, we have to have a higher river stage than the stage in the basin. When the river is low, like often during the summer or the fall, we're unable to get a lot of flow into the basin. But when it's higher, like it is right now, we're able to pulse it and to get several thousand cubic feet per second flowing into the basin to moderate salinities. The diversion is located on the west bank of the Mississippi River. It is in St. Charles Parish, and if you're familiar with the Luling Bridge, it's maybe about 3.5 miles or so east of the bridge. It is composed of 4 gated 14 by 14 foot culverts that run underneath the Mississippi River levee. Each one can be operated independently, and by lowering and raising those gates, we're able to control the amount of water that's actually flowing from the river and into the outflow channel. So the outflow channel, which is shown on this picture here, it flows under River Road, 2 railroads, and then under Highway 90 before it discharges into a ponding area, and then water flows further south through the Barataria system and into the Gulf. So the maximum discharge of this diversion, this is when we have the optimum high river stage and a good head differential between the river and the receiving basin. Maximum discharge is 10,650 cubic feet per second, but we limit it to 10,000. Just keep a bit of a buffer there. All right, so we have multiple collaborators, as I mentioned, with this project. The project was constructed by the Corps between 1997 and 2002, and we started operations in 2002, with 2003 really being the first year of full operations. Operations, maintenance, and monitoring costs are shared between the Corps and CPRA. They fund the majority of it at 75%, and CPRA funds 25%. CPRA manages operations and monitoring of the diversion, but we collaborate with St. Charles Parish, who actually performs the daily operations of the structure and also performs a lot of the maintenance that's associated with the project. So next we'll talk about some of the project features and talk a bit about the ponding area and the purpose for the ponding area. If you look at the top, that's where the structure is actually located. The Mississippi River is at the far northwestern corner of this slide. Water flows from the structure, through the structure, down the outflow channel. It's about a mile long, and it then enters a ponding area that's about 9,400 acres, and that is delineated on this map with a yellow line. The purpose of the ponding area is to have an area where water kind of slows down and is concentrated for a while, where we have nutrient uptake by the marsh, and we also are able to enhance sediment deposition in this area where it's already shallow, where it's close to the diversion inflow, and where we can expect to see really some of those additional benefits. The ponding area is bounded by guide levees on both the east and the west, and there is also a rock weir that is along the southern boundary, right there along the northern shore of Lake Cadawatchee. The reason for the rock weir is to slow the movement of water out of the ponding area and allow for that nutrient uptake and sediment deposition in this area. When it was initially constructed, if you look at this map here, you can see that there's several channels that flow out through the rock weir. Initially, we thought we'd be able to have enough water just flowing over the weir, but it vegetated rapidly. We had shrubs growing on it and trees. So we needed to actually gap it in order to allow for increased flow out of the ponding area and a reduction in water elevation within the ponding area. We also needed to raise the elevation of the west guide levee as well, and just to keep water, when we're pulsing and when water level comes up in the ponding area, to keep it in the ponding area and not from overflowing. We have a pump station that is used to allow for a continual southward flow of water in the northwestern part of the ponding area. When we built the West Guide Levee, that blocked that natural flow of the southern flow of water. So the pump station kicks on when we reach a certain water level on the outside to allow that water to continue to travel southward through the ponding area. We have a USGS real-time flow gauge that is installed right at Highway 90. So at any time, you can go online and you can see how we're flowing, what discharge we're operating at. And so we use that to help us gauge how we operate the diversion. And then we also have 2 coastwide reference monitoring system stations that are within the ponding area, and also known as CRIMS. This is a monitoring system that CPRA has across coastal Louisiana. We have around 392 stations coastwide, both in marsh and in swamp habitats, where we measure a multitude of parameters, which I'm going to talk about a little bit more in a second. All right, so with every project that CPRA does, obviously going to have a goal, we're going to have objectives. The main goal of this project is to utilize a controlled Mississippi River diversion to reduce saltwater intrusion in the Barataria Basin and to maintain that estuarine gradient in the basin with fresh marsh in the north and salt marsh in the south. So the Barataria Basin, it has experienced a lot of marsh loss, and with that marsh loss, it's allowed for saltwater to travel more rapidly and more easily up into the basin. So the goal of this project is to be able to operate this freshwater diversion to push that saltwater, further south in the basin. The objectives that are expected to be attained through operating this diversion is to enhance emergent marsh vegetation growth, to reduce marsh loss, and to increase the productivity of significant commercial and recreational fish and wildlife. So we monitor for all of these different things so we can report on how the project is functioning. And these can be seen as a broadening of benefits. All right, so next we're going to talk about operations. And this is a picture from the Mississippi River looking straight on at the diversion, looking down the outflow channel. So first off, I did want to explain that CPRA and the Corps, we're not the only ones that are making decisions as far as how the diversion is operated. We have 2 different groups. We have a technical working group. It's a smaller group that's made up of a representative from the Corps and also from state agencies, including Wildlife and Fisheries, Department of Environmental Quality, and a Department of Conservation and Energy. So their main purpose is to come together and recommend to agree on a plan, an operations plan, to recommend to the larger Davis Pond Advisory Committee for the upcoming year. So every year we draft a new plan. We then propose it to the Davis Pond Advisory Committee, which typically meets maybe a month and a half later. This committee is made up of the members of the technical working group, as well as members of federal agencies, from parish government, for the parishes that are impacted by the diversion. We have representatives from fisheries, representatives for landowners, and also a representative from the Barataria-Terrebonne National Estuary Program. And the primary purpose of this larger committee, it's about maybe 20 people that serve on this committee, is to advise CPRA's executive director, who's Michael Hare, and serves as the chair of the DPAC on information that's relative to the diversion's operation, and then to vote and to agree on an operations plan for the upcoming year. So if we don't have, an agreement, so we go back to the drawing board and continue to discuss it and come up with a plan that we agree on. And I wanted to mention there are other responsibilities these groups have as well. These groups review data that is collected each year, and also historical data, and use this information to help inform discussions about diversion operations. So they'll review annual reports, provide feedback. All right. So I guess we'll start with base flow versus pulses. The diversion operates at a base flow of 1,000 CFS. This is how we're operating if we're not pulsing. This is just to maintain, a bit of a connection between the river and the basin to allow some fresh water to keep coming in on the northern side of the basin. So we can pulse above base flow, so operate over 1,000 CFS when two conditions are met. One, the river stage needs to be relatively high in relation to the basin, and also salinity has to be above the low salinity limit for the gauge that we're using at that time to gauge or to guide operations. So there's two different things. And the reason why we pulse really is, it's to moderate salinity in the basin, but it's meant to simulate the seasonal overtopping of the natural levees that used to occur often, in late winter, early spring, when the Mississippi River would rise and then overflow its banks. This process would provide fresh water, fine sediment, nutrients, dissolved oxygen to the coastal marshes and to the swamp. But of course, we needed to raise the levees to protect people that live along the river. So now these controlled diversions operate to kind of mimic those seasonal pulses. The photo that is on here, this is very recent. This is from March 17th of this year. We were pulsing at that time, and we are still pulsing. We had a mean discharge that day of 6,575 CFS. And you can see the sediment as it's moving through the ponding area and then traveling through Lake Catawatchee and then traveling down into Lake Salvador. So that was a great image that really showed the transport of the water through the system. All right, so I'm going to talk a little bit about how we operate. We use real-time gauges that are maintained and operated by USGS, another collaborator of ours. The plan uses two primary gauges. We have the Grand Terre gauge that is located further south on a 15 part per 1,000 target isohaline, and we have the Bay Dogri gauge that is located further north, and that is located on our target 5 part per 1,000 isohaline. We also have two reference or alternate gauges we can use if one of the other gauges goes out. We have the Mud Lake gauge and the Hackberry gauge. So the isohalines that are shown on this map, they are to provide a general idea of where we want to maintain salinity in the basin throughout the year. It's not a hard target where we are looking to have 5 parts per 1,000 at the Bay Dogri location all the time, or 15 parts per 1,000 at the Grand Terre gauge all the time. It's understood that salinity changes seasonally. It gets higher during certain times of the year. It gets lower during certain times of the year due to multiple factors. So they're intended as a general guideline where you're looking annually in the basin. And it was decided this was really the optimum range to benefit wildlife or to benefit fisheries, especially oysters in the basin. All right, so this might look confusing, but it's actually pretty simple. This is a graph showing our freshwater diversions operations plan for 2026 for the Grand Tear gauge. Like I mentioned, there's two different gauges that we use. We use the Grand Tear gauge for half of the year. So this is used January through June and in December. And then we use the Dogri gauge from June through November. So the area that's grayed out on here is when we are not using this particular gauge for operations. And when I say for operations, I mean we're using this gauge to determine, to see the salinity in the basin and to use that salinity to determine whether or not we are going to increase operations of the diversion or decrease it based on salinity. So the line that goes through the middle there with the dots on it, that is a 10-year monthly mean salinity, and that is what we use to come up with a operations range for the gauge that we're using at that time. Bay Dogri has a separate range based on salinities at that gauge. We then have a plus or minus 1 standard deviation range that we develop. That's the black line that is above and below the 10-year monthly mean. And then what we do is we look at salinity at the Grand Tear gauge, and we calculate a 14-day salinity moving average, and we graph that on here and see where it falls. We can only pulse when this 14-day salinity average is going to be above a low salinity trigger. So on this graph, it's all that area that's colored in on red. It's the area below the -1 standard deviation of the 10-year monthly mean salinity. So essentially when the salinity gets that low, when it drops into that range, we can't pulse. If we are pulsing at the time, we have to return to base flow because it's fresh enough. We don't need to add any more fresh water to the system. But when it's above that, we can pulse. For this gauge, it's always going to be -1 standard deviation of that mean because this gauge is located further south in the estuary. It stays pretty salty. But at Bay Dogri, it will sometimes be that 5 part per thousand salinity that is the trigger to return to base flow. So it's the higher of either -1 standard deviation of the 10-year monthly mean or 5 parts per thousand. Also want to point out that we have 3 consult periods with the Louisiana Department of Wildlife and Fisheries that are based on brown shrimp emigration into the estuary, and that is for the month of March, that's right now, and then also May through July and September through October for oysters during important times then for reproduction and harvest. So during these months, we will reach out to them. We will tell them what we're thinking on doing as far as operations, get their feedback, see if they're seeing like a lot of shrimp come into the estuary, and just coordinate with them as far as how we operate. Also, I wanted to point out that all of our operations plans, as well as all the information, all the documents, the monitoring plans, everything for the Davis Pond Diversion, Freshwater Diversion Project, and CPRA's other projects as well, can be downloaded from our Coastal Information Management System, SIMS, at the address that's provided. All right, so this slide shows what discharge actually looks like. This is from 2025 for Davis Pond. We had multiple pulses, mainly in the beginning of the year. Discharge is on the y-axis, and then the months of the year along the x. So let's see, yeah, we pulsed really, a couple times through May, and then we had some smaller ones later in the year. Looking at main daily discharge and how frequently we pulsed above base flow, it was about 178 days, almost half of the year. One thing I want to point out on here is there are multiple reasons why we have to sometimes close the diversion or limit flow. We reduced to base flow during 2 weeks during duck season to reduce water elevation. We also had to close multiple times because of coastal flood advisories that were issued for the parishes that are impacted by the diversion. So at that point, we'll shut down. We'll also shut down if just water level reaches a certain elevation at a gauge that we monitor. And we'll also have to shut down if there's, a spill in the river. We'll close the diversion just to be careful in that case. And also sometimes the river is so low that we need to shut down to prevent any sort of backflow through the structure. Okay. In the red line that's on here, this is that indicates the base flow target. Right. One more, this incorporates both discharge and salinity. So I want to focus on the figure that's on the left. That is the one for Grand Terre. Again, that's used for 6 months out of the year. The graph on the right is for Bay d'Augry. That's what we're using the other 6 months out of the year. The red line, if you look at that on the Grand Terre graph on the left, that is the 14-day salinity moving average. The blue line is the discharge. So in the area that is shaded blue is when that gauge is used to determine operations for the diversion. So we did pretty good. I mean, it's mainly within the operational range. It did get a bit higher in April, and we were pulsing then. We did have to close temporarily because of a coastal flood advisory, but then we opened back up, we were pulsing, and then the salinity did begin to come down. So we remained within the range most of that time. And then, so if you look at Bay d'Augry, we remained within the range most of that time as well. One other thing to mention, we use the 14-day salinity moving average and not just instantaneous salinity, because salinity can change really rapidly in the basin. There are other things that impact it other than the diversion, obviously. Precipitation can cause a sudden change in salinity, as can wind, a change in wind direction, a change in wind speed, a change in the tidal range. Within a day, you could potentially see an increase of salinity as much as 10 parts per thousand if the winds start coming strongly out of the south and start pulsing, pushing Gulf waters up further north in the basin. So in order to take out some of that rapid fluctuation, we use the 14-day salinity moving average just to kind of even it all out and see more of the trend and not change our operations in a reactionary way. And then this figure is just to show our annual mean discharge in 2025 and also annually all the way back through 2023. The red line is our long-term average. And in 2025, we actually surpassed that. It's the last time we had done that was 2013. So we did focus on operating a little bit more in 2025 based on a recommendation of our Davis Pond Advisory Committee. They recommended that we try and maximize diversion operations while staying within the operational guidelines of our plan, because salinities were starting to come up a little bit in the northern part of the basin. And we did that and had a higher mean operation than we've had for several years. All right, so next we're going to talk about monitoring. The picture, remember this picture that I'm showing right here, this is at one of our CRIM sites. It's CRIMS 3169, where we conduct tours, we bring people out there. Notice all the trees in the background. That is something we'll talk about in a few minutes. All right, so for the Davis Pond projects, we have a 50-year operations, maintenance, and monitoring plan. This year, 2026, is year 25, so we're just halfway through that. And we write annual OM&M reports, operations, maintenance, and monitoring reports that bring in data throughout the Barataria Basin, and we look at that data in relation to Davis Pond operations, in relation to how the river stage was that year. And those data types that we look at include hydrologic, vegetation, spatial, wildlife and fisheries, and soils elevation change and accretion. A lot of this data comes from our CRIMS monitoring network. We also have USGS data, that is, our hydrologic data, project-specific data, and we use Louisiana Department of Wildlife and Fisheries data. We look at waterfowl, alligators, oysters, shrimp, blue crab, finfish. All of this will be included in our annual reports. I'm going to show just a few of the different assessments we do and some of the data. This is an assessment of salinity from 2024 in the Barataria Basin. We have 69 hydrologic stations throughout the basin. The ones that are like fuchsia, like pinkish looking colored with the white outlines, those are the 4 real-time USGS gauges that we use for operations. Most of the other ones are continuous. They're not real time, but they are continuously recording salinity as well as temperature and water level. So for this analysis, those are all annual mean salinities. For 2024, did an interpolation in GIS to see where salinity was generally falling in relation to those 5 part per thousand and 15 part per thousand target isohalines that are both marked on this map. So in 2024, it was more saline. You can see the 5 part per thousand line was north of the 5 part per thousand target, as was the 15. And some years it's like that. Years when the river is higher and we get more precipitation, you can have those lines much closer to the target lines. It just depends on a lot of different factors. So the blue is, the freshest, of course, and it's the freshest in the northwest and northern part of the basin. It's also fresh down in the southeastern part of the basin because of the Mississippi River influence. The water coming out of the Mississippi River will come up and move up into the basin. So when you have a really high river year, you do see more freshening of the basin because of that inflow of the river water from the south. We had our highest salinities more in the western, the southwestern part of the basin, where the highest mean salinity was about 22.5 for the year, and the lowest was 0.1. We also look at vegetation, and this is vegetation at CRIMS 3169. That's the slide that we looked at that had those trees that were growing behind the marsh. This CRIMS 3169, it is in the direct flow path of the diversion. It's only about 4.5 miles from the structure, and it receives significant input of sediment from the diversion. CRIMS 3166 is a bit more outside of the direct flow path. It's in the south. So we're going to focus on 3169 really quickly and take a look at this. What's really impressive about this station is even though this diversion is a freshwater diversion, it was not constructed to specifically deliver sediment to the basin, it does receive fine sediment off the surface of the river, so silts and clays. In the 25 years or so that it's been operating, we've had a significant buildup of sediment and elevation at this CRIM site. We've had a lot of mineral sediment come in and settle out, which has resulted in this site transitioning from floating marsh, where you wouldn't be able to even get out and walk on solid ground, you would sink, to attached marsh, and now to a forested community. So we added a forested transect to this marsh station in 2021. This is the only site that's part of the CRIMS network where we've done this. And it's because all that sediment's come in, the elevation is come up, and willows have come in everywhere. So there are other species that are present, like Baccharis, woody species, wax myrtle, buttonbush, we're seeing red mulberry. But right now, as far as monitoring along our forested transect, because the trees have to reach a certain height or a certain diameter at a height. They are all black willow, but we expect in years to start seeing recruitment of other species as well. And the figure that I'm showing there, that's just to give an idea of how species covers have changed over years at this project site. This goes from 2008 to 2025. This is at along our marsh transect, not our forested transect. This one has the longer timetable, so I'm using this. And we have vegetative cover, percent vegetative cover on the y-axis. So the thing to point out here is black willow, that's the black color that's on this graph. It's increased tremendously. Starting in 2013, you can see how that's changed. So this is a site that has actively been transitioning into a forested habitat. This slide shows it probably better than a graph does. This shows imagery of the CRIM site, where it's located, CRIMS 3169, from 2010, where it was all marsh, to 2016, where we started seeing the trees come in, to 2024, where we really don't have a whole lot of marsh left there anymore. And then the picture aside of that shows a soil core that we took out at CRIMS 3169. And this was just maybe a year or two ago. You can see all the gray soils there. Those are all the mineral sediments that have deposited from the diversion. And then you can see below that all the organic material, all the organic marsh that was there before, that is now like further down, and all this sediment has been deposited at the site. So it's really impressive. All right. Also wanted to mention that we use a lot of data that is collected by the Louisiana Department of Wildlife and Fisheries. This is also something that we assess in relation to diversion operations. It's fisheries independent monitoring data, so it's data that's collected from specific LDWF sites, and we do have additional sites that were added specifically to collect data for Davis Pond. They provide annual reports to CPRA that summarizes fisheries data across the coast, but they also have a lot of reports on their website where you can get really detailed information about oysters and shrimp and finfish. So I recommend you go check that out for more information. All right, I'm just going to show you eastern oyster data and brown shrimp data, because those are the two species that we have consult periods with LDWF for our diversion operations. So the eastern oyster, this figure here shows past 10 years, breaks down seed and sac oysters by barrels. So LDWF does 1 meter squared sampling every year in July to assess the oyster resource on public seed grounds. They have divers that go down, they drop these plots, and they do an assessment of the stock. Seed oysters are less than 3 inches long. Sac oysters are greater or equal to 3 inches long, and these are the oysters that are actually harvestable. Just wanted to point out that in 2024, we were looking good relative to some of the previous years. We had an increase in both seed and sac oyster that year, and both were above the 10-year average. Right. And then we'll also just look at brown shrimp. This is the dominant shrimp that's landed during the spring inshore season. The shaded area on these figures is when, since the diversion started operating in 2022. LDWF has a really long data record. They do say that the past 10, maybe 11 years, the data are most consistent for sampling technique and stations, but the records go back for like the 16-foot trawl all the way back to 1966. So in 2024, we saw an increase in both 50-foot seine catch per unit effort. We also saw an increase in the 16-foot trawl. And for the 50-foot seine sampling, the catch per unit effort was actually the highest recorded since the first year of data in 1986. All right, so going back to just kind of summarize the engineering with nature and how this project fits so well with that. It uses natural processes. It's a freshwater diversion. It uses Mississippi River water to moderate salinity in the Barataria Basin. And the diversion has promoted natural land building within the ponding area, even though that was not its purpose. It produces efficiencies. The rock weir that was constructed along the southeastern rim of the ponding area, it enhances sediment deposition and retention within the project area and also allows for greater nutrient uptake of the marsh, in the marsh. It broadens benefits. There's been an expansion and enhancement of wildlife and fisheries habitat, especially in the ponding area. With river sediment deposition fostering a transition from floating marsh to forest habitat in areas that are receiving direct flow. And it also has promoted collaboration. We collaborate with the U.S. Army Corps of Engineers as our federal sponsor, as well as other federal and state agencies, St. Charles Parish, and other stakeholders who are all part of our advisory committee. And that's my last slide. Thank you.
Fantastic presentation, Danielle. That was awesome. Just want to note to folks who are watching, if you've got questions or comments, if you want to email them to us at coastal@la.gov. We'll be glad to try to get to as many as we can before the end of the hour. And if there are any others beyond that, we'll shoot you an email afterwards. So we do have one question, and at the beginning of your presentation, you talked a little bit about the Carnarvon diversion, freshwater diversion, that's on the east side of the river in the Breton Sound, as opposed to the Davis Pond in the Barataria. How different is it, kind of operations of Carnarvon as opposed to Davis Pond?
Right. So Carnarvon is kind of the sister diversion to Davis Pond. It was constructed earlier. It was constructed in 1991 or began operating in 1991. And it's further downriver. It has a somewhat smaller capacity because it's further downriver. It's about 8,000 CFS max capacity. We deal with a somewhat different situation in the Breton Sound Basin lately than we do in the Barataria Basin. The Breton Sound Basin has more freshwater inputs that have expanded with Mardi Gras Pass and with Neptune Pass. And so because our diversion operations are salinity based, it actually means we don't get currently the ability to operate as much. We don't get to pulse as much as we can for Davis Pond, where the salinities have been a little bit more stable in that basin. Right now, we have to operate at base flow because the gauge that we use for operations right now, Snake Island, the salinity is below our low limit. Whereas that is not the case for Davis Pond. And for Davis Pond, we're able to pulse right now because the system could still use some more fresh water. So there's just more of a freshwater input naturally through the river right now. I'd say that's one difference. We also have revised the monitoring plan for Carnarvon to be focused on just one gauge, whereas Davis Pond, we use two different gauges and we switch back and forth during different times of the year. We use only the Snake Island gauge at Carnarvon, and the salinity ranges that we use there are not based on the previous 10-year mean monthly salinities. They are based on a range of salinities that we received from Louisiana Department of Wildlife and Fisheries for the eastern oyster. So operations are based for that diversion more on salinities for that species.
Fantastic. Well, thank you very much. I'm not seeing any other questions at this time. Thank you for your presentation. The graphics,
Thanks.
Your presentation were so easy to understand and follow.
Great.
What you were talking about. Greatly appreciate it. Want to invite everybody to come back again tomorrow. Brian Gospin will be here, and throughout the week, and help us celebrate Coastal Week as we move forward to Coastal Day on Monday, March 31st. So thank everybody who tuned in today. We appreciate you taking the time and spending it with us, and we'll look forward to seeing you tomorrow. Have a great day.